Hello and welcome to Fundamentals of Historic Brick and Mortar, which is presented today by AIA Virginia's Historic Resources Committee. I'm Rhea George with AIA Virginia, and as folks are joining us and getting their audio connected, I'm just going to do a couple of quick housekeeping announcements before we get started. If you happen to get disconnected today from Zoom, just hang on the line. You should get automatically reconnected. And if you get one of those low bandwidth warnings that we sometimes see, you might want to consider closing any programs that happen to be running in the background. And of course, finally, please feel free to engage with each other on the chat. If you know of a great resource, please drop it in there. Feel free to add your LinkedIn profile. And of course, add any questions to the Q&A tool. It looks like two little cartoon chat bubbles, and that will allow our moderator to address those towards the end of the session. If you happen to see a great question in there that you'd like to hear answered, please give it a thumbs up, and that'll bump the most popular questions to the top, so our moderator is able to prioritize those. Today's course is approved for 1.5 AIA learning units, HSW. Watch your email tomorrow for an automated message that's going to serve as a confirmation of your attendance for your records. We'll also include some resources and a survey, so please let us know what you thought about today's program. For those of you that provided your AIA member number when you registered, I'll report credit to your transcript within 10 business days. But if you happen to be joining today's session from a conference room where you're logged into a single Zoom profile or you're joining by phone, please go ahead and just add your name and member number to the chat so I can make sure to get your attendance recorded as well. I'd like to take just a quick second to acknowledge and thank all of our speakers today. Amanda, Warren, Susan, and Anthony, we're really grateful for your willingness to share your expertise with us. And of course, speaking of thanks, I would like to take another moment to acknowledge and thank our very generous sponsor, LimeWorks. It's through support like theirs that we're able to bring programs like this to you today. So with that, I'd like to invite Anthony Hita with LimeWorks to say a few words. Anthony?
Thanks, Rhea. Well, it's a pleasure to be here today. Brick, stone, and mortar are some of our oldest and most ubiquitous building materials, but as modern materials and methods have increasingly replaced traditional building techniques, it's becoming apparent that working with heritage materials requires a more specialized knowledge and intentionality not universally possessed. The consequences of ignoring the distinction between historic and modern are often harsh, as choosing the wrong materials or failing to consider the conditions that affect older buildings can lead to severe and rapid damage, turning relatively cheap maintenance repairs into expansive and expensive condition remediations. At LimeWorks.us, we are manufacturers, educators, and mentors in the use of historic masonry materials, including the use of lime mortars, plasters, stuccos, and paints for historic preservation, and also for modern sustainable building systems. Our products, classes, services aim to equip professionals and amateurs alike with the material, skills, and support they need to protect our worldwide architectural heritage. We aim to bridge the gap between architects, engineers, owners, and practitioners. Today, in pursuit of this goal, we're happy to partner with AIA Virginia this afternoon to host this talented group of individuals who have extensive experience in historic masonry preservation. We hope that you will find their experience and perspectives enlightening and valuable. And so with that said, I'd like to turn it over to our moderator, Susan, to take us into those presentations.
Thank you very much, Anthony. As AIA Virginia's Historic Resources Committee has been thrilled to present the series of programs on issues that are very important to historic preservation, as Anthony just mentioned. Our previous webinar was on historic windows, making the case for their restoration versus replacement. And today we are thrilled to present the historic brick and mortar. And I'd love to introduce Warren Davies and Amanda Edwards. Warren will be speaking first, followed by Amanda. And Warren Davies is a masonry expert and historic masonry consultant at Virginia Masonry Restoration in Richmond, Virginia, a third-generation brick and stone mason with 30 years of experience, specializing in historic masonry restoration and preservation. He consults on historic projects throughout Virginia, has served as an expert witness related to historic masonry and civil court cases, and has taught many workshops and classes in masonry restoration. He is trained in the use of traditional lime mortars under Jimmy Price of Virginia LimeWorks and holds several certifications on the use of masonry restoration products. And we also will hear from Amanda Edwards. She's an architectural conservator and associate principal at MTFA Design and Preservation in Washington, D.C. She brings a wealth of knowledge and leadership to the team. She's been responsible for the preservation of some of the nation's most iconic buildings. Her experience includes materials testing and analysis, condition assessments, and construction documents for the preservation and stabilization of a wide variety of historic buildings. So Warren, thank you very much.
Okay, thank you, Susan. I just wanted to make sure I was unmuted there. It's funny about this. My wife almost doesn't allow me to talk about masonry when I'm in the house because she's so sick of it. And then I get an opportunity to talk about masonry and I somewhat freeze up. So I'm going to do my best to get through this. This isn't something I do every day. I looked at the program and thought, what is it that I wish more people understood about the lime mortar and the way it's used and how it impacts the restoration business or just the endeavor overall to preserve some of our old structures. And I thought to myself that what I run into when I talk to masons locally is so many of them don't understand a couple of the primary benefits of lime mortar. You could probably go to slide 2 and then 3 if you want, Rhea. There are several benefits to the use of lime mortar, but the two that really matter are the fact that once the mortar is used, it's laid in the bed joint and your building is built with it. The mortar isn't adhering the bricks together. The mortar is acting as a cushion. And if you look at that picture there and you see that kind of rustic brick wall, you can see that the brick are kind of wobbly looking, and you can tell that this building has gone through some movement, but you don't really see any cracks. You see very few, if any, cracks in the bricks, any structural cracks. What you see is that the building has moved, but very little damage has been done other than to the fact that it has worn the mortar away. And this isn't something you would see with if you were using modern mortar with these soft clay bricks. The normal expansion and contraction that every masonry building goes through every day, depending on humidity and temperature, would end up putting pressure on the bricks that isn't there because the lime mortar is absorbing those changes as it expands and contracts. So you find that the use of this mortar allows these buildings to last longer. These bricks last longer, and therefore they're going to be around for a long time if they're taken care of. The other thing that is a real benefit to using lime mortar is that the mortar is the main pathway by which water is evaporated once it is absorbed into the structure. If water gets in by being absorbed through the mortar and through the bricks, or through holes in the wall, or from the roof above, or around window openings or sills, anytime water gets in, the fastest way for that water to evaporate out of the building and therefore cause less chance of damage to any of the interior finishes or mortar rot to the structure itself, it's if it has a healthy pathway of mortar by which to evaporate that water. And the problem we face is that if masons and architects and owners don't understand the primary two benefits of lime mortar, that that it is a flexible material that absorbs movement, and the fact that it is a pathway for the evaporation of water, then they will continue to make the choice to use modern mortars to do their repairs, rebuild walls, do repointing jobs, and that will, in the end, cause these buildings to deteriorate more rapidly. The use of Portland cement-based mortar, when you do for instance, a large wall repair, means that that section of wall has no flex in it where everything around it does. And so what starts to happen is the energy that's created from that flex, the expansion, the contraction, whatever settling or movement goes on, it starts to manifest itself in the face of the bricks. If you go down to number 4, Rita, you'll start to see an example of Portland cement having been used to repair a brick wall. And in this case, what you're seeing is spalling. If you have a solid, hard material like a modern cement with no give in it, and it in fact doesn't evaporate water nearly as efficiently as lime mortar does, then when a wall is totally saturated and it goes through a freeze-thaw cycle, the wall expands and contracts more dramatically. And the only place for the release of that energy is at the face of the brick, less so the underside and the backside, because in many cases, there's still some lime mortar around. So all of the pressure is right at the face. And it starts microscopically at first. You often go from a nice smooth brick to a somewhat textured brick. And then you'll finally get to the point where you see what you see here, which is chunks of brick are falling out. And in many cases, half the brick will disappear before the mortar joint looks any different at all. You can move on to the next one, Rita, number 5. It's the same picture, but it just has some information there. So I think that if masons had a better understanding of why we were asking them to use lime mortar, especially for any kind of historic structure, I think that they would adapt to using it more quickly. I think many masons, and I know this from talking to them, they think that the specifications are silly sometimes. It's just architects making rules. It's there's all kinds of justifications for feeling the way they do. But I think very few of them end up feeling that way for long if they get some sort of logical explanation as to why it's important that these mortars get used and that these properties are brought to the forefront and that everybody starts to understand the benefits of it. I think a lot of the time when I hear about, I heard we're supposed to use lime mortar on this old house. Well, fair enough, that's true, but very few hear why. And that's something that's missing. If we could move on to 6 for a second. Also want to mention something about the, many of you may have seen buildings where the bottom of the building, all the mortar joints are missing, Then at the top of a building, say, like along the parapet line, a lot of the mortar joints are missing. A lot of the time, tops of chimneys, the mortar is missing. And it's interesting that in case after case, you're more likely to find damage at these locations than anywhere else. And the reason this is happening is because in those places where they're exposed to weather, down at the bottom of the building, they're getting all the stuff that's running down at the ground level. It's wicking up and saturating the wall. They're also getting the splash from around the house, splashing up onto, the bottom 2 or 3 feet of the wall. These parts of the wall are staying perpetually damp. They're more damp more often than other parts of the wall that are getting good wind. The upper parts of the wall, where they're up in the sunlight and they're seeing greater extremes in temperature, they get the early morning sun and the hot afternoon sun, and there's less weight holding all of that masonry in the chimney together. And so when they freeze and they're saturated with water from rain from the previous days or weeks, the expansion is greater, and these chimneys start to lift up at the top, and then they shrink back down a little, then they lift back up, and it's all microscopically at first, but over time, just like if you were to go dig a hole in a field and try to put all that dirt back in the hole, you'll find that the dirt won't all go back in there very well. Well, the same is true with this mortar. As it expands and contracts, it isn't going back together very well, and eventually the joints at the tops of these buildings become more open, and the weathering you see in the deep joints are more caused by the expansion and contraction than they are by any sort of erosion. It's that movement, constant movement, that's causing it. And with less weight, and you don't have the whole weight of the roof system and the whole weight of the building helping to compress, you'll find that up there things go haywire a little quicker. And that is another good reason to have a flexible mortar in the joints and to have an ability to evaporate that water quickly so that those areas don't stay saturated when we go into freeze thaw cycles. Okay, yeah, let's move on to this. I think there's a couple of things that are worth knowing when you're trying to talk, especially to, you might be talking to really good, talented bricklayers, masons, or whoever, who may have never come across this stuff. And so it's important that they understand that lime mortar can be temperamental, and a lot of the success of the repair is going to depend on the procedure that's followed for that repair. And if you look at this picture here, you'll see that I think in the second joint down, you'll notice that there's a sort of V where somebody has run a blade or a tool and they've cut the mortar joint out. I don't know the numbers, but I would venture to say that 90% of guys that clean mortar joints out in preparation for repointing do it exactly that way. And what's going on there is you're leaving residue on the walls of the brick. And when you squeeze the new mortar into that joint, it isn't actually adhering to anything but dust. It's really important for the function of that repair that the joint actually get cleaned, like the third step down, where all of the debris and dust is removed from the upper and lower brick, and that you cut a nice square back. And the rule of thumb is typically 2.5 times as tall as the joint. So you do that so that when the new mortar is squeezed into the joint, you can get full purchase on the brick. It's actually adhering to the brick, not the old mortar. And if you have it deep enough and clean enough, and you've put the mortar in 2 stages, one stage kind of acts as a sort of bonding coat. It also ensures that you don't put so much in there that it's likely to shrink as the evening goes on. You want to have that first coat go in and smear it onto the walls of the brick. Then when you put the second coat in, what you have is a repair that is stuck so well to the brick that during freeze thaw cycles in the future, the movement isn't likely to just pop those joints right back out, which happens in many, many cases. A lot of the tuck pointing repairs repointing repairs that we see are because they didn't cut the joint deep enough, and they are repointing and sticking it to the mortar that's slightly behind rather than worrying about how well it's bonded to the brick. And then you'll notice that that joint is slightly recessed from the face of the brick, not flushed or smeared onto the face of the brick. I will get to the striking of the joint here in a little bit, but I wanted to mention a couple other things along the lines of how important, how temperamental mortar is and how important the preparation is. When lime mortar is used, the curing process depends on the complete control of moisture, both in the substrate and in the mortar mix itself. If the water hasn't been soaked to the point where it won't immediately draw the moisture out of your mortar, then that mortar is going to effectively die. Lime mortar in general is going to join with a brick building and start to become part of a living, breathing thing every day. But if you put that mortar in and all the moisture is sucked out of the mortar before it has had a chance to chemically cure, then the mortar becomes a different substance altogether. And eventually, usually within a year or two, that mortar will just turn to powder, and it will be no good at all. So it really requires an understanding that you don't create a situation where you have so much suction from a dry, thirsty wall that the mortar gets killed. Conversely, if you have soupy mortar and you put that into a saturated wall, that mortar will not cure well either. It is going to be a chemically different product, and it will shrink dramatically, creating microscopic cracks, which will later become the places where water infiltrate and expand and contract and then start to deteriorate the mortar. Another thing that I think that is really, really important, and nobody really talks about this, that you'll often see in a set of specs, not to retemper the mortar. I can't overstate this. Once a mortar has been mixed, and usually you let it sit for 5 minutes, maybe 10, 15, and then you give it another mix. Once you start using that mortar and you've gone on for an hour or two, you don't want to let that mortar get hard and then suddenly add more water to it and then stir it back up and try to reuse it. That mortar is now a chemically different product. If you add water to something that's been curing for an hour or 2 hours and it's now gone stiff, you are now changing the chemical makeup of that mix. And that mortar will also turn to powder and will be ineffective. This is something that I struggle with our guys constantly. It is the hardest thing in the world to accept when you just add a sprinkle of water and all of a sudden it looks just like it did when you first mixed it. But we have ran into situations where we are having to go back on a job a year or so later because the mortar has turned to powder. And it's always in like one little spot here or there. And you can always tell that it's in a situation where somebody tried to get a little bit, didn't want to make a new batch, and they got the stiff mortar out, sprayed some water in it, tried to shake it back up and use it. not enough masons understand the reason why that specification is written. And I think along with some of the other things I've talked about, like the flexibility and the evaporation potential for lime mortar, I think it's really important that at the beginning of jobs, architects have a conversation with the leaders of some of these companies and say to them, this is going to compromise the long-term success of this repair, of your repair or the work in general. Okay, I'm gonna leave that, and can we just, are we on, we're on 8. I want to talk a minute about, before I get to the striking of the joints, which I will, I just want to have a quick note about the choice of bricks when doing repairs. I think all of us have seen, when we drive down the road, any number of old buildings that have these very bright repairs with very fat joints on the front. It happens a lot under windows or above windows, in places where the brick structure is typically weaker. This is where you're going to see these larger cracks. And I want to point out that that there are all kinds of creative ways to overcome having to do a repair when you don't have the exact brick that was there originally, or you don't have the right size brick. And so just a couple things I would say in order to perhaps help any masons that are looking to solve these kinds of problems before they do a repair. First and foremost, for me, it's very important that I am always at the brickyard. Any of the brickyards locally, I tend to go there, don't even go inside. I go and walk the yard, and I look and I see all the bricks that they're carrying, what's in stock, what size are they, what color range do they have, what's the texture, and I just get a mental picture of things that are available to me. The other places I go are to construction salvage yards, places that sell antiques that might also sell antique building supplies. A lot of them will carry old cobblestone, old brick, old windows, you name it. It's important to go to those places and see what they might have as well. It's actually probably more important for us to go to places like that because they may have tripped across a brick that is very difficult to find. And in a lot of cases, I will just buy it, even though I don't have a clue when I'm going to use it, because I know eventually I will be desperate to find a brick just like that. Another thing that I think would help people in helping solve problems for repairs and restoration is when you choose brick, whether it be from a handmade wood mold pile of that are new, going in, or whether you have gone to a salvage yard and you're peeling from a pile they have, look for the largest brick they have. Large brick, especially if they're longer, they can really help you overcome a lot. They help reduce the size of the head joints, and so it makes your repair look a little less conspicuous. If you have enough of these large brick, you can, if you've got a 1.5 inch split where the masonry has separated, if you had 3 or 4 of those in a row in a course, you can eliminate that split and get it back down to a normal size joint in no time. And the same is true for taller bricks. If you put in a brick that's just slightly too short height-wise, it makes your repair look ridiculous. That joint looks way too big and you can see it from blocks away. Better to just be on the constant hunt for bricks that are probably too big. You can always cut them down, you can cut them shorter, whatever, but you're gonna have way more benefit to dealing with these problems that inevitably come up. Another little trick you can do is, if you look in the picture in front of us, you'll see that this is a Flemish bond. Every other brick is a header, which as it appears on the outside, it looks just like a half of a brick. Well, when you're trying to do a patch repair, sometimes you can cheat and get rid of some fat joints by, instead of using a whole header fully inserted, you can maybe turn a brick and maybe cut it to be slightly longer than a half. So if a half is 4 inches, you might have one that's 4 3/4. And if you put that in a place where the wall has separated, you'll find that when you're looking at that wall, nobody's seeing that extra 3/4. That repair has just disappeared. And so those are just some things that you can, if you get masons telling you, well, this is the best we could do, this is the only brick we can find, I find that there's always a way. And you just got to get more creative and ask the right questions and see where you end up. Okay, so I did want to get to one other thing, which is about the mortar joints, the way that we strike the joints. I think that we all face the problem of having to match the color of the joint. And there are debates about whether to match the surrounding masonry, clean or dirty, whether to cut masonry out of the wall and try to match it to something inside that's untouched by pollution and stains and whatnot. And all of those debates are there still to be had. But one thing that I think would really help the quality of repairs is if people, rather than just taking their striking iron and filling the void and flushing the joints up, maybe putting a little tool mark in it and brushing it, rather than do that, if you'll notice in some of these brick here, you'll see that underneath the edges of the brick, we have sliced the mortar away just enough to put like a 1/16 of an inch or an 1/8 of an inch reveal on the brick below, on the brick above. You can see it on the head joints on the ends of the brick. And although the joint has not changed size, what you've done is you've reduced the overall appearance of the joint. And so if you're only repairing a 3 foot by 3 foot section of wall, when somebody drives by, they're going to have to work pretty hard to find your repair if you've done things like this. This way of making it look less conspicuous actually casts a shadow on the joint and darkens the joint without changing the color. And it makes it grab the eye less when you go by. So there's all kinds of things that often have to be done to make the finish of a joint look similar to the original. But I think this technique of cutting the joint after it started to go off is very helpful. This is something that doesn't happen within the first half an hour. This is something that you may lay the brick or repoint the brick, and 3 hours later, you come back and do the cutting. And then maybe 3 hours after that, you do the brushing, or maybe even the next day, depending on the temperature. Anyway, these are just some things that I think I wish more masons knew that these tricks were at their disposal. And I also wish they knew a little bit more about the behavior of this lime mortar, how temperamental it is, how they've got to take care of it. And then, of course, we talked about the water and how the wall needs to be soaked enough to maintain a balance of moisture between the mortar and the brick. I think that's especially true after the work has been done. Covering the wall with saturated burlap or painter's cloths, and then a tarp just to keep the humidity, not soaking the wall. I think that anytime you're misting or soaking the wall, you're almost creating a lens for the sun to kind of burn the surface of the mortar. So it's more about maintaining the humidity. And then you can see in the picture that Ria's put up here, you can see a before and after. The way that the joints on the stone were originally pointed, they were just smeared, flushed up everywhere. And then once it was restored, if you look on the right, and if you move on to the next picture, you can see a little better. These joints were cut with recesses, and it allowed the look of the stone to show rather than the eyesore that was the previous repair. I want to go to two other things, sorry. The next picture, 11, Ria. That section of masonry, those are the same section. This section on the left, this was what was done right before we were hired. And, you know, this was considered a completed repair. The picture doesn't do a great job of showing it, but the brickwork was actually running downhill here. And so what we had to do in order to make this brickwork look like the rest of the building was a process called tuck pointing, which is a system where we flush all of the joints to match the color of the brick. And so you now have a red mortar in the joints all the way across. And then you come back and then you put a thin bead of mortar over that red joint. And you'd have to zoom in pretty good. I don't know how well you're able to do it here, but you'll start to see that there are little shadows of red mortar around each of these red bricks. I don't know if you can zoom in there or not. But it's pretty subtle, but all of these brick have it because it was an attempt to hide the poorly laid repair and the fat joints that were there. Now this section of brickwork, although it's full of all kinds of strange brick, it looks more like the rest of the building. And when you drive by there, you can't see it. And then lastly, if you go to picture 12, I just want to make the point that in my discussion about tricks and ways to make a repair disappear, this building had a serious fracture in it. And we not only made that fracture disappear, but 40% of the surface area that you see in this photo has been repointed or rebuilt. And if you look close, you'll find places where you can see that the mortar is a slight shade off, or the joint might be look a little heavier. But for the most part, what you get is that this is a repair that disappeared into the wall, and it would take a little bit of work for anyone to find that it ever happened. And that's really what I think we're all shooting for. So that is all I have for today. Amanda, I think you are next.
All right, thanks, Warren. So Rhea, if you could go to my slides. Rhea, are you going to start my slides, or should I share my screen?
Yep, working on it. Just give me 1 second.
Okay. So while Rhea's doing that, I'm just going to recap. My first slide talks about the wall system that Warren already discussed. So I'm just going to recap it rather than go through it all again. So the important thing is to understand the properties of mortar and how they work in a wall system. So we know if the mortar is harder than the bricks will crack. You don't get that cushion that Warren was talking about. If the mortar is impermeable, like a cement-rich mortar, it will prevent water absorption through the joint, but it could also trap moisture behind it, not allowing that evaporation. That permeability is really important for the wall system. And then we also want to make sure that the mortar is uniform across the wall so that it reacts to the stresses in the same way. So Warren was talking about those thermal movements and differential stresses. And if we have mortars of different strengths and permeability and even hydraulicity, then the wall is going to perform differently and could have pockets of deterioration. So historic construction understood these properties, and as preservation architects, it's really important to understand how to repair those walls. And mortar analysis is one tool that can be used to determine the mortar compositions for replication. In these two photos, the top one there, the original mortar looks to have been too hard, and the moisture was coming through the face of the bricks, these glazed bricks, instead of through the joints. And then at some point, it looks like it got repointed, but not to a proper depth. And the mortar has failed universally. And then down below, this is taken from an 1820s courthouse in Virginia, where some of the repairs were made with Portland cement, which certainly wouldn't have been compatible with the lime mortar that was found in this building. All right, you can go to the next one. All right, so what are the mortar components that we're trying to understand? So mortar is made up of aggregate and a binder. The aggregate, of course, is your sand, and the binder can be either hydraulic or non-hydraulic. So a non-hydraulic binder could be something like clay, which hardens simply by drying, or it could be a lime, which hardens by carbonation or reaction in the air. Or it could be hydraulic, and hydraulic means that the binder has significant amounts of alumina and silica, mostly related to clay-rich limestones. And these impart a hydraulic property, meaning that it can, the mortar can set up with water. It doesn't need to rely on the carbonation process from the air. Go to the next. So what are the types of mortar that we'll find in historic buildings? So there's a lot of different kinds of mortar that are present. So I don't think you can always assume it's one way or another depending on its age. And I'll explain below, a lot of these were happening at the same time and available at the same time. So you can have lime mortars where we have a pure lime putty. We can have natural hydraulic lime, which is lime that has some of that clay component in it, which creates the hydraulicity. You can have cement, which also goes back to these hydraulic clays. And then you can have cement and lime. You can have natural cements. You can have clays. So again, the mortar analysis helps us to see better what kind of mortar would have been used. So hydraulic limes were discovered in 1756 by John Smeaton. He was in England. He was experimenting with mortars for a lighthouse. And the common practice at the time was to burn the whitest limestone to get the purest lime. But he was experimenting with burning clay-rich limestones. And he discovered that when he did that, his limes actually set up underwater, which is a great property for a lighthouse. So hydraulic limes can harden both through carbonation and through the chemical reaction with the alumina and the silica and the clay. By 1796, James Parker of England decided to try burning clay and adding water to it. And he created this really hard cement. And it was called Roman cement, but it really was one of the first natural cements that was used. And then in America in 1818, in Rosendale, New York, there was a really large supply of this clay limestone or argillaceous limestone. And when that was processed into these cements, it was called natural cement, and it had a really good permeability. So, the moisture could travel through the wall. It was very good at flexibility, but it also was very strong. And so they were introduced more for the use in engineering, like the building of canals and things like that. But natural cements had a long history in the US until Portland cements became discovered. So in 1824, Joseph Aston discovered Portland cement in England, and he did this by, again, taking that clay-rich limestone, burning it, and making a slurry. But then he burned it again into a powder. So that double process is really what creates the Portland cement, and it's called Portland because it is the color of the English Portland stones. This cement gained strength 2 times faster than natural cement, but it was a bit more brittle when it was used in the wall. It was produced in the US by 1871, and its speed and strength beat out natural cement. And natural cement was phased out by the early 20th centuries. But understanding that you can have hydraulic limes, hydraulic cements, natural cements, and artificial cements is really important when you're looking at the mortar components that you discover in your analysis. Go to the next one. So what kinds of mortar analysis are there? The two different kinds that are most commonly used are gravimetric analysis or an acid digestion and petrographic analysis. So an acid digestion is really, it's weighing the acid soluble versus the acid insoluble parts of the mortar, so the binder and the aggregate, so that you can get a ratio of your binder to aggregate. But really the purpose of an acid digestion is to release the sand for matching. So a lot of times the color of a mortar does not rely on pigments, but it does rely on the sand color. And that can be a great tool to when you're looking to replicate something. Acid digestions really don't tell you much about the composition of the mortar, however. They don't tell you much about the quality of the lime. They don't really reveal the hydrolicity. So it's sort of, in fact, they did a couple of tests where they took known compositions, did digestion, and they couldn't get the analysis to reveal what those original compositions were. So it's not great for finding your mix ratios. But a petrographic analysis, on the other hand, uses microscopy and chemical analysis to really determine what those binder compositions are, the aggregate characteristics, the hydrolicity, and the mix ratio. So you get a lot more information from your petrographic analysis. So just a quick note about sampling. When you're sampling for mortar, you need at least 40 grams, and more is better. And you definitely don't want a sanded mortar. You can't get a lot of information if it's already turned to dust. You need those nice hard clumps. You have to determine if you're trying to replicate the pointing mortar or the bedding mortar. In some cases, they can be the same. And finding a good opportunity to collect these samples, especially on an active construction site, looking at where the some of the demolition might be happening, you can reach in and get some of that good bedding mortar. Next. Okay, so when you're doing an acid digestion, I just wanted to walk you through some of the steps. You can get your oven dried mortar and you weigh it. Then you grind it up in a mortar and pestle. And then you dissolve the binder with hydrochloric acid in your laboratory hood. And once all of the binder has been dissolved, your aggregate is exposed and you weigh all the different portions. You can go to the next. And again, with the acid digestion, the best part about it is that it does release the sand. So if you sieve the sand, you can get your sand size distribution and compare that to the ASTM C144 standard. In this chart up above, the blue lines represent what the analysis was, and the black lines show the range that's acceptable for ASTM. And in this case, the sample was a little bit finer than the ASTM standard. So you're also looking at any additives in the sand, if there was brick dust or, hopefully if there's oyster shells, it didn't get dissolved. And you're looking at the quality of the sand. Is it round? Is it angular? Gives you some indication of perhaps where the sand may have come from. Next. And then once you do all of your calculations, if you're looking down if you circle sort of 10, 11, and 12 there, you can look at the ratio of the sand with the ratio of the fines. You add those together compared to your acid soluble part. And typically it is a 1-to-3 ratio. But that's all it really tells you. It doesn't tell you much about, again, the composition of the mortar. Go to the next one. So petrographic analysis, on the other hand, gets further into these details. So you do start out with optical microscopy the same way that you would do acid digestion, just to try to understand, you know, what's in this mortar. Can you see any lime lumps? But of course, with petrographic, you're using polarized light microscopes as opposed to stereo microscopes. So you can see a lot more detail. In this case, the areas that are circled in yellow are unburnt limestone seeds that are indicating that this is a natural cement binder. It's definitely something you wouldn't be able to see in a regular microscope. Next. Then you take the microscopy to the next level with the scanning electron microscope and the energy dispersive X-ray spectroscopy. And what this does is it gives you an elemental analysis of what is in the paste. So you're looking at how much lime does it have, how much silica, how much aluminum. And then you can also calculate the cementation indices for the different sampling. And that tells you if the paste is hydraulic or not. So if it's not hydraulic, this is the last column on the chart that says paste CI. If it's not hydraulic, it would be less than 1. If it is hydraulic, it would be greater than 1. So again, already we're getting a lot more information. Next. So with petrographic, there is still the acid digestion and the sand analysis. Next. And then you can do further chemical analysis, which really gets you to your mix ratios so that you can understand the binder to sand to make sure that you have a better understanding of what the actual components are. Next. And then you can also use petrographic analysis if you have issues with the mortar, say there's a salt contamination, you can do some salt testing to understand what kind of chlorides there are and perhaps try to pinpoint where the issue is coming from. Next. So when you're doing your replication mortars, you really need to understand what question you're trying to answer in order to figure out which kind of analysis to use. So if you're simply trying to match color and you already know what the strength of the mortar is, and you're really just trying to do sort of a quick analysis, then an acid digestion may be exactly what you need. If you're trying to understand the properties of the mortar, how hydraulic is it? What kind of lime was used? Does it have any cement in it? Then you will need to go to a petrographic analysis. The other thing about when you're trying to figure out what to replicate, you need to ask yourself the question, how important is it that I use the exact same formula that was done originally? Maybe what you discover through your petrographic analysis is that it was using a half and half calcine clay that may be difficult to find in modern times, right? Can you install a mortar that affords the same properties, the same hydrolicity, the same permeability, but in a slightly different composition? And I think when you use petrographic analysis, you can start to make that determination of what that replication mortar, what those properties should be. But then on the other hand, if you're working on a historic building of very high importance where, returning to the original methods is part of the interpretation of the building, is really important in the longevity of the building, then understanding what the actual components are and trying to figure out how to source all of those can become very important. So I hope this gives you a good idea of when to use what kind of analysis. And, I think one of the things that we're learning in doing these analysis, for me, at least for these past 20 years, that there really weren't a lot of pure limes that were used in some of these historic buildings. I think the hydrolicity of mortar, these hydraulic mortars, have been in development for a long time. They didn't just start when we had natural cement, or didn't just start when we had Portland cement. So I think that's been very interesting to understand how limes themselves can be hydraulic and how they were used in the US. And there's a growing body of evidence about the technologies that these different components gave to the mortars. So thank you very much.
Thank you very much, Warren and Amanda. That was absolutely fantastic to hear your presentations. And we have just over 30 minutes. So what I'd like to do is ask some questions of you and Warren and Anthony, and then we'll open it up for our Q&A. We have several great questions in our Q&A tool, so we will address those. So please, if anybody has any questions, just type them in and we will get to those. First, I wanted to ask just a general question about both to Warren and Amanda. What are your biggest challenges? So availability of materials, sand sourcing, environmental issues, just whatever they may be that you find the most. Amanda, do you want to start?
There's a lot of challenges. I think sourcing materials is one, like Warren was talking about, trying to find brick that matches and always sort of hoarding those special bricks that when you find them. But I think there's also issues in the application of the mortars, trying to get the conditions right. And Warren, you probably can speak to this better, but you pick a color in a channel and then you put it in the wall and they're totally different. And how do you get that consistency from, the thing that you really want that you've selected, and how do you get that to work in the wall? And sometimes, especially in a stone building, the moisture content of the wall can vary the color of the mortar dramatically from one day to the next. Like I had a situation where I put mortar in on a Monday, it looked one way, put it in on a Tuesday, it was a completely different color, all the same mix. So getting consistency and sort of allowing for a little bit of variation is a challenge, I think, and communicating that to the team. I don't know, Warren, you got anything else for that?
Well, without hesitation, I would say my biggest challenge is finding people who have already been in the masonry business, who have the willingness, wherewithal, or ability to adapt to the sensibilities of doing this kind of work. I meet so many guys who are such good bricklayers and really do have a talent for doing, artful brickwork, but they, for the life of them, cannot accept the way we have to do things when it comes to historic preservation and restoration. There's the cure times in the way that we have to, if we're going to clean something, there are certain dwell times that last a certain amount of time. Getting used to not being able to use high pressure when we clean, mixing up giant batches of mortar and just making that be the batch you use all day. The small and incremental approach that we have to take is so much at odds with the way bricklayers today have to make money. And, the way they have to make money is brick in the wall, brick in the wall, brick in the wall. And everything is kind of dumbed down. The way that they strike, they all use a concave joiner, which is the most forgiving joiner in the world. So you can lay brick that are kind of wonky, leaning in and out, and this and that, slightly off on. But these joiners, you do super fast, slick them, let it sit for a bit and brush. They're very forgiving. Whereas what we have to do is just so time consuming, meticulous. And so not only have I got a problem with guys that can execute with that kind of spirit, but I'm also finding that we have to bid against people who only know their way. You get a contractor who does 95% of his work building CVS's and or new homes or doing this and that. And he suddenly gets, because of some relationship with a contractor, invited to bid on something that's historically sensitive. Well, I have to bid against a guy who doesn't know how long it's really going to take to clean those mortar joints out and to get all the dust out and to get the finish done and how many times you have to revisit it. And so it's one of the reasons I'm so interested in trying to educate my competitors even. You know, I think it's a win-win all the way around if more people knew. It's nice being one of the few, but it isn't that nice. You know.
And actually, leads to another really important question, Warren, is about the availability of craftspeople that are trained, as well as the materials, if you could address that.
Well, there are very few available, and we have found that we have better luck hiring guys who have done some level of apprentice work with a production masonry company, or none at all. It's almost better not to bring those habits with them. I mean, those habits serve them well in that part of the business, and there's no way I'm knocking that part of the business. It has to work that way. But when they come over, when they bring some of the habits they do with them, it's often a fight. And if I hire anybody who's similar to my age, well, you can forget it. It's, you know, it's hard. Guys don't want to take criticism. Guys know it all. I mean, I know a lot, but I know every day that I'm about to learn something. And that's the approach you have to have in this end of it. And it's just hard to find guys like that. I find guys that have been laying for 10 years and they think that they're master masons. And there's just no hierarchy or structure for masons that allows us to really put a label on someone and say, well, you're this good right now, but you can be this good. It's kind of a free for all. And so that is a problem. Going younger is better for us right now.
And maybe Anthony, if you could speak to the availability of good information. I know for so long, Preservation Brief 2 was what there was, but if you could speak to information and maybe new technologies in mortar, that would be great.
Yeah, sure. In regards to what Warren said about finding the right craftsperson, you also have to find the right specifier and project manager. And often people are operating on out-of-date information. The one that gets thrown about the most often is Preservation Brief 2 from the National Park Service, which is well written and for the time was the best knowledge that was available, but it was written in 1998. We didn't even start investigation into the damaging effect of Portland cement until the early 2000s. So it still recommends a type N Portland lime mortar or type O, when the most recent specifications by the Park Service and the Secretary of Interior standards actually tell you not to do that at all and to try and replace, if not in kind, then at least with sympathetic properties. So I feel that one of the challenges is also, if you are an architectural professional, to continue doing continuing education, continue attending things like this, so that you're aware of what's going on out there. And, you know, every once in a while, go back and read through those copy pasted specs that you just modify slightly for a project, because I can usually tell at this point when a specific architect has written a spec, because the same language appears throughout it and the same mistakes. So just like masons need to constantly be willing to learn, those of us on the conservation and architectural side also need to be willing to learn, no matter how long we've been in the business. The frontier right now for lime technology is distinguishing the differences between limes. Right now, the historic battle has been Portland cement or lime. Once in a while, natural cement slips in there, but we've kind of taken those things as monolithic, pun not intended. And the problem is that we're finding out that limes, different brands of natural hydraulic lime, have different properties. Air setting limes versus hydraulic limes, the use of various pozzolans in air setting limes, and then even different types of lime putty, whether it's made from hydrated lime or quick lime. all of those have very important effects on the masonry system. And so it isn't quite as simple anymore of just saying, well, preservation briefs 2 says use a type N. That's what we're going to do. It needs to take a little bit more intentionality and a little bit of comfort in saying, you know what, I don't know the answer to this. Let me call an expert or bring in somebody onto my team who can then be that expert.
So I did add a couple of documents, or Ria's going to put them into the chat maybe, or into the email. One is they're all from APT, and one is about the ASTM 1724, did I get that right? Which is about specifying for historic mortars. There's a really good article that explains.
Yeah. 1324.
Well, not petrographic analysis, but the one for historic mortars. Anyway, Ria has it. I don't have it off the top of my head, but and then I also added a couple of articles on mortar analysis that were really well researched in APT. So there's some resources there that we could share too.
Great, thank you. And also, Amanda, if you could talk a little bit about any discoveries in analysis or trends or things that are changing and evolving.
But I think Anthony, started that conversation where it's exciting to learn about these different limes and the properties that they impart on the mortar. Like you said, it's not just about cement versus lime anymore. It is about understanding the wall system. How is it breathing? How is it flexing? How did these limes, and more importantly, the pozzolans, like you were saying, how did the additives to the limes change the property of the mortar? And a lot of this, part that I find very interesting is it's really lost when you do these acid digestions, which have been so common for so long. And it's only when I've started doing much more petrographic analysis that I started to see these nuances. And I think that's really where the research is going. And I think we're going to learn a lot more about how these historic buildings were intended to be done as a system. Anyway, and the hydraulic nature of these mortars is a lot more prevalent than we thought.
I think now we have quite a few questions in our Q&A, so let's pivot to our Q&A from our audience. So this first one, Warren, I'll pass this to you. What is the best tool to remove old mortar without damaging the brick?
Well, purists would tell you to use a hammer and chisel, no mechanical tools, but we have found that the tool that does the least damage to the brick and is the most efficient is a tool called an Arbortech. This is a tool that's made in Australia, and it basically has two oscillating teeth that go into the mortar and chew the mortar without touching the face of the brick at all. So you can actually go in and just notch out one brick and pull it out without affecting anything around it, clean this out, and then replace it with a healthy brick or whatever reason you had to open it. If the joints are too tight for that, then I like to use, say you're using pressed brick, with the real skinny joints, I might use one of those little hand drywall saws and just shave that mortar out. And you'll find that on a lot of pressed brick projects, the mortar doesn't go all the way through the bed joint anyway. It was kind of buttered on the edges and then plopped down. So the middle is often hollow. So you find it's fairly easy to go in and cut them with that, but that or a 5-in-1 tool. But in terms of most lime mortar, common brick removal, the Arbortech has been phenomenal for us.
And then that brings the question of what about when your repair has been Portland cement and you're faced with Portland cement versus your lime?
Well, with Portland cement, knowing that it's so hard that any impact on the Portland is going to disperse energy onto the face of a very soft clay brick, the goal is to do what you can to disperse the energy when you have to impact it. So what we tend to do is cut a groove with a very thin diamond blade right down the middle of a joint. So that becomes sort of a relief cut, and then take a sharp 5-in-1 tool and just tap away from the brick so that the energy is going down into that void that you've created in the relief cut, and same underneath. And it's a very delicate thing. It's almost impossible to do it without pulling some of the corners, where the mortar has been smeared. It's very difficult to do without pulling some of that original brick away. But in the end, if it's carefully done and then replaced with a mortar that allows everything to flex and breathe again, then it's probably a sacrifice worth making. Now, I will say I have seen Portland cement repairs that were smeared so heavily onto the face of the brick that there's no way that it was going to help to tear that, because it would tear so much of the face off. And that's a hard call to make, but sometimes that's the way it is.
Great. Another question, what was the source of lime in historic masonry construction? So for example, kilns, but also the actual source of the lime itself. Amanda or Warren, do you want to start?
So the source comes from limestone, right? So it's the burning of limestone that starts the lime process. And I think, what the research is showing now, so there's it's kind of a long answer. So, if you're talking ancient times, you're still looking at limestones, but perhaps they were using these clay-rich limestones that we were talking about then, but we just aren't really sure. That's where those Roman cements may have come from. We do know that there was a proclivity for burning the whitest, clearest limestones, and those would give you the most pure lime. But in the United States, I think it was more likely that they were using a lot of these clay-rich limestones, these argillaceous limestones, as their source material. So then they do get burned in a kiln. And there's an article I could probably share that talks about what the different kilns were. But it is sort of a regional source.
And another question, Amanda, can you elaborate on how to translate the analysis into a specification for construction use?
Sure. So there's that one article that we put in the chat that really explains what a specification should include. And I think that why I do this is really trying to understand what these properties are. So if I find that it's a natural cement mortar with a lime additive, then I know that that is available, so I can specify that. If it is a hydraulic lime, I can specify an NHL and look at the properties of the different types of NHLs to see which is going to really match the properties that I found in my analysis. So you really need to understand what products are available and what each of those products do, so that when you're getting your analysis, you're creating a mix that is compatible with the existing.
Warren, a question, whoops, I just lost it, about spalling brick and repairing it. So someone is saying that past advice has been to use water glass to consolidate the friable surface. So can you address other ideas or solutions for spalling brick?
I can tell you that I only really know of one company that makes a product for consolidating friable surface, and they are reluctant themselves. This is Kime. They are reluctant to endorse their product for use for brick. They see it more for friable surfaces like marble, statues, and monuments, things like that. I can say that for the most part, I find it more practical to just replace the brick. I think at best all you're doing is slowing. There's no way, even if you put some sort of consolidant on the front, you're still going to get a buildup of moisture behind it, and you're going to have these expansions, especially if you've done any repointing. The whole thing will expand and contract, and it just seems like it's just all you've done is delay the inevitable, and not in a way that's pretty.
And if I can jump in just for a sec too. So, you know, when you have a fireable brick face, you've essentially lost your fire skin. That brick is no longer functioning as it should, right? So it is deteriorated beyond the point of repair. But I will say that there was another question, I think, in there. Can you repair, you know, holes and stuff in bricks with lime? I will say that if you do repair a brick, the brick should be repaired as a unit, and the mortar should be separate, so that you're not trying to bridge the joints with the units. And so maybe that's with a patching mortar or a crack repair. But typically when I'm out on site and I'm trying to determine the level of repair, if the fire skin is gone, if the bricks are cracked, if it's, you know, more than 50% of it is gone, that's a replacement brick. That's not something that I'm going to try to fix.
And what about on an interior? Would you have a different consideration for interior spalling brick or even skim coating it? You know, a wall.
I think the interior, if you have a lot of damage on the interior of your brick, you have to really understand what the source of the damage is, because that sounds like it's more of a systemic problem than it is, you know, simply a mortar or moisture infiltration. It could be related to it could be related to rising damp. It could be related to the HVAC and temperature controls that are sucking moisture through those bricks and sanding them. I did recently have this issue, and it was determined that it was a rising damp issue coming from, you know, really porous bricks, very old handmade bricks, and it was just sucking up moisture from a foundation that was full of clay. And, you know, in that case, we got structural involved, try to understand if those bricks if they had to be replaced or if they could still stand, and anywhere that you can keep the bricks that's desired. But it was really a case of us trying to resolve the moisture infiltration and then let the bricks dry out. So it is a case by case basis, but I'd say that's more a deeper investigation as to why that's happening is required.
I would also say about that a lot of the interior bricks are going to be salmons, which were a generally softer brick anyway.
Right.
So that's not going anywhere good either. There's, I think, very little reason to keep a spalling brick.
We have two related questions about locating masons who have the knowledge and experience for this work, but also when there is difficulty in locating qualified masons, how about learning the skills themselves, so training?
Are you talking about homeowners
Well,
learning?
yeah. How do people find the qualified masons? And then when you can't, what if somebody wants to actually get the training and skills themselves because they're not finding anybody else?
I think that's tough. It takes so many years to have seen so many aspects that you have to be able to bring to bear all kinds of problem solving skills and an ability to almost forensically interpret what's in front of you for one thing. I mean, you might look at the front of a house and see a crack that zigzags down and think, I can fill that crack and do a good job of it. But it's unlikely that you've done anything other than fill a crack. There's a fracture there. There's a way that has to be tied together. And somebody has to be able to not only interpret what it would take for it to stay fixed, but also what caused it in the first place so that they can choose from the best selection of fixes. I think it's also very hard to get the touch and the feel with the mortar and the finishing. One of the problems that I see a lot is that it looks great when it's wet and finished that day and you brush it and you go home. But when it dries, you can see it from Mars. And if you haven't done it a few times, you don't know that this pretty thing you did is going to look that way. And it's a very difficult place for a homeowner to be in. So depending on what it is and how prevalent it is in sight of the public, I would be a little reticent to go down that road.
Yeah, I'll say that I repointed my basement and I taught my husband how to do it. And, I'm somebody that I'm not a contractor out on site doing the work all the time. I'm just observing and the analytical side of things. It was a difficult process. And I would say that, I hoped my skills would have been better, and I hoped, training my husband would have been better, but, you have to sort of do the trial and error, and it really is about the feel, and it's hard to learn it on your own without somebody showing you what that feel is. But it can be done. You just have to give yourself a break.
I do have a suggestion for people in this situation, and I've been in this situation quite a few times. A lot of the time people call me and there's no way that I can get to their job. But what I will tell them is, if you find somebody you like and seems trustworthy and you want to have me have a conversation with them, or if you want me to assess something so that you can compare and see if they have hit some of the same notes, it might help you know whether you've got somebody who has this kind of sensibility or not. And there have been times I've been paid to be a consultant, and there have been times I've just been the friendly consultant. But having somebody to call and get a second opinion on the person, because all of us, all Masons, think we are the best. So you're inevitably going to get somebody who feels very strongly about their talent. So it's not the worst thing in the world to get a second opinion.
Let me throw in a resource for you as well. As a retailer, we get this question quite a lot because we service both homeowners and professionals. And we've been putting together a network of professionals at www.craftworker.net. And this is not something we're ensuring or guaranteeing the work, but for folks who want to post a project, it is free to do so. And then people who buy our products, who are in our network, who have opted into that, will get notified about it. It's usually a really good way, especially if you're in Northeast. We're trying to grow the network beyond the Northeast, but right now it's really Philadelphia to Boston where most of our people are. They're able to contact you directly. Now you still got to check their insurance, check their references, ask for mock-ups, take Warren up in his offer to talk to them, that sort of thing. But at the very least, it can get you started. Because we often get asked about that, and we don't make recommendations because a lot of our customers are in competition. It just wouldn't be fair. So that's our attempt to try and sort of level that playing field.
Excellent resource. Thank you, Anthony.
Nice.
Also, the Department of Historic Resources has a craftsman's trades directory, kind of in similar vein. It's there. They're not specifically making recommendations. Everybody does still need to be followed up on, but DHR does have a directory as well. We have another question about stripping paint off of old brick, which is something we encounter quite a lot. I don't know, Anthony, or
I can answer that one too.
Amanda, good.
I do a lot of testing to try to figure out, what product is going to work the best. You do have to kind of know what paint is on there. And you always want to start with the gentlest strippers that you can, and then work your way up toward more aggressive. And, you know, it's going to take probably more than one application to do that. But so it's being patient. There are times when I've tried various methods like sponge blasting or, you know, some sort of media to help speed up the process. And I'll have to say that usually end up going back to stripping because it's more gentle. The most difficult stuff I had to take off is that acrylic Acryl 60 cementitious basement coating. Sometimes people apply it to whole buildings and that stuff is really difficult to get off. But I think it's just looking at the various strippers. You can look at the Smart Strips, Smart Strip Pro from Dumont or the Prosico, heavy duty paint strippers, things like that. And just sort of do small little tests to see which one's going to work the best before you apply it wholesale and how many applications it might take.
And what arguments would you give to people who want to paint an unpainted brick building? How do you counter that argument that, oh, the paint will protect it?
All about permeability. So making sure that your wall can breathe is the most important part, because if you trap moisture in that wall, then you're going to deteriorate those bricks from the inside out. A lot of modern paints are breathable. Latex paints are breathable. There's different categories of breathable paints. So there's a lot of science that can be applied to understanding what that permeability should be, like a water vapor transmission rate test. But for an average homeowner, it's just, you know, painting isn't, an unpainted wall is the most breathable wall. Painting will trap that moisture a little bit, but just making sure that you're not plugging up the whole porosity of the wall system. It's very important.
And it becomes a maintenance nightmare, because when you're painting over brick and you've got voids over little pockets of mortar, or where the transition between the brick and the mortar, it bridges those gaps. And as the house expands and contracts, they open up into tiny holes. And when water gets behind them, they blow these out. And then trying to paint the next coat on top of this partially peeled mess, it just gets worse and worse year after year. And it's got to be far more expensive than whatever bit of maintenance it would have taken to maintain a wall, clean it or whatever. It's a nightmare.
Yeah,
I'd
you do
also
want to
like
be
to add one other thing there too. Go ahead, Amanda, you're about to say something.
I was just going to say, you want to be careful about how many coats you have. The thicker the paint, you know, the harder it will be on your surface. So go ahead.
I just want to also add a word about the dangers of fashion. It can be very fashionable to paint your building gray. 20 years ago, beige was the color. And you may go out and find a mineral paint, for example, that is perfectly compatible with brick, but becomes semi-permanent on the surface. And yeah, it's not going to damage the building, at least so far as we know with our current knowledge. But in 20 years, when now hot pink is the color or whatever, you're now stuck with that. So it's very important to consider when you're using it, when you're in a historic building, that it's something that may belong to the ages beyond just the resident who's in there. And I always just caution people, when you're thinking about changing the aesthetics of a historic building, take some time and really sleep on that decision before you commit fully to it, because you may not be able to go back easily.
And one last question, we are just about out of time, but about bricks. There are two, they're related. One is, can you use modern brick in a repair for a home that is 200 years old, or should you find old bricks? And then there's a sort of related question about soft clay bricks versus modern bricks that are kiln dried, and just sort of appropriateness of brick in repairs with historic buildings.
Me?
Yeah, Warren.
Well, I can think of very few instances where we've had to use a modern hard modulus brick in a repair on an old structure, almost every time we're able to find what we need to do repairs. And it just takes a bit of legwork and a bit of patience, and you know, deadlines are important. But when you start to know you're going to do this kind of work, if you can start reaching out to people and seeing what you can find, it's better for it. Using those hard brick, you now have something against which this other soft structure is now rubbing and interacting, and that's when you're going to start to see little cracks going here and there over the years, because it's not expanding and contracting together anymore. They're kind of, in a way, working against each other. So if you can avoid it, I wouldn't do it. But if you've exhausted all, I have had to once or twice.
Wonderful. Well, we are at our time. Please, if you have some takeaways or surprising things you learned today, put them in the chat. Ria is going to do a follow-up article in Inform Magazine. I'm sorry we did not get to all the questions. There were lots more great questions, and maybe we can follow up in our email with some additional answers. But thank you so much to Warren, Amanda, and Anthony. This has been extremely interesting and helpful. We really appreciate your time, and thank you to everyone for joining.
Thank you.